is Remote Daily, your daily dose of inspiration. This is Remote Daily, an oasis of innovation for your mind, your soul, your heart. Connect, guide, and recharge with Remote Daily. This is Remote Daily.
But I'm just looking at the chat and wow, everybody has so many amazing questions. I mean, each one of these is worth, like I said, I think I was saying before, you know, it's worth a bottle of wine and a whole evening, every single one of these. I just would love to talk to you about all of this. And of course, I'm not going to have time. So maybe I can just start in with some of the ideas here. You know, in some respects, I actually find this kind of comforting. And I think some people also find it sort of disturbing. The word life is something I've never really been very comfortable with, because we talked last time about how we're made of the very same chemicals and the very same elements that the stars make. And somebody had asked the question, you know, why do we think life elsewhere would be based on carbon and use oxygen? And of course, scientists are not that limited. Of course, we don't think that's necessarily the case. But there's a reason, and there's a good reason why we're based on carbon. Carbon is something that dead stars make very easily. The clouds between the stars are full of carbon. In fact, I brought you something that's actually older than the sun. This is a meteorite, a slice of a meteorite. And this particular one, if you see it, it has some tiny little silver nodules in it. I'm kind of pointing at one at the top of my finger there. And these are something called chondrites. And chondrites were the very first matter in our universe to solidify. We started from I should say in our universe, our solar system, we started out of this cloud, and the cloud was rich in all the elements that come from dead stars, because the cloud was formed by the debris of dead stars. And there was static electricity as this cloud moved around, and clouds rubbed against each other, much like lightning is created today. And where you had a lightning discharge in this cloud, even before the sun formed, it melted little droplets of the material, and they became a little denser than everything else. And gravity began to sort of bring things in together around these little globules here. And this is actually one from a meteorite. And this meteorite we know is older than the sun because of the chemistry. The sun's gravity drew most of the heavy elements into the middle of the solar system. So most of the heavy stuff like gold and iron and silver and everything ended up inside the sun, because that's where the gravity was pulling all the denser material. And this little guy here doesn't have any of that. It's heavy and light stuff are all jumbled up. So the other thing that this has is it has more organic molecules, more different sorts, more nucleobases, things that make up DNA, than my body uses. Meteorites are filthy rich in carbon, more chemicals than our bodies use. Our bodies use only a tiny little subset of these. And it turns out that carbon has all these electrons that love to stick together. And I've actually posted, I think Felix will share with you, a funny little video from the European Union about if chemical elements were at a party. You know, there are some that really want to react and some that really want to fight and separate from each other. And they have this all as actors. It's really kind of fun. At the end of the party, some are fighting, some are having sex on the table. I mean, it's just really, you know, hilarious. And, you know, the thing is that all you need is the reason why water is so important, and it may not, I'll talk today about where life might not be based on water, is water will dissolve all of these organic compounds and allow them to move around and form bigger and bigger bonds and bigger molecules. And I'm not kidding when I said that there's DNA nucleobases in here. One of the things we do at NASA is trying to figure out what life on another planet would be like. It might not use the same chemistry, the same organic molecules, even if it's based on carbon. So what would DNA be like based on the things in here as opposed to the things on our body? And life, you know, the chemistry can move around a lot. I have another thing for you today. I have a little piece of the planet Mars. This tiny little rock that you see kind of against my skin there, that's a little Martian meteorite. Something hit Mars so long ago that the little rock was launched into space, and it actually fell back down on the Earth as a meteorite. And in the Martian meteorites, we find amazing organic chemistry and possibly even signs of life. I mean, that meteorite you heard about decades ago that had little worm structures in it, we still don't really know what those are. So to me, when I go to Yosemite and I sit on the rocks, you know, these gorgeous, huge, unimaginably beautiful, powerful things, I feel like I'm there with my older sisters. You know, there's no magic differentiation between life and non-life. It's just a matter of complexity. And there are things that we find in nature that we're not even sure are alive or not. These are things that are sort of at the very boundary of life. One thing is something called a prion, which is a protein that can make copies of itself. That's one of the things that life started, you know, molecules that could begin to make bigger and bigger copies of themselves. And for those of you that know anything about the sort of the medical stuff, prions can be very bad diseases. They specifically can take over things like brains. Mad cow disease is an example of a prionic disease. And another thing is viruses, interestingly enough. Viruses are so small. Most viruses are only about 1,000 atoms across. And they are, of course, unable to reproduce on their own. They just inject their own molecules into a cell and get the cell to make copies of it. So, you know, they're so tiny, it's kind of unbelievable. Here, I'll share a picture just of some of these things. We'll talk a bit about sort of the boundaries of life. Hold on a sec, let me share my screen with you.
Just wanted to jump in as well and say thanks, Michelle, for
oh sure
for winging this when we don't know whether we have Felix or not, or don't have Felix. But I can once we've seen some of these, I can then facilitate the conversation in terms of some of the questions that are coming through. So thank you.
Oh, absolutely. So, you know, I showed, this is a little electron microscope of some viruses. And there's a tiny little bar at the bottom that says 100 nanometers. I mean, like I said, you could fit about 1,000 atoms across these things. They're really, really tiny. And there's a little thing over here that shows the biggest thing that you see in the bottom one is a dust grain compared to a red blood cell. And then a bacterium, and a virus is smaller still. I mean, whether a virus is really alive or not is something that's hard to say. And the origin of life, interestingly enough, never stopped. People thought there was a moment when life came into being, and that was a mystery. It's not so much. Let me show you some pictures. The moment of the genesis of life happens every day around the world. Life is created from chemistry. It's just that now there's something else to eat it, and there didn't used to be the first time that it happened. Now, this is a picture of something called a black smoker, a hydrothermal vent, a vent of hot water heated up by the lava and the heat of the earth at the bottom of the ocean. And the warm water is rushing out into the cold water at the bottom of the ocean. And there's a tremendous chemical reaction. And as you can see, the water is rich with minerals, you know, silicates and organics, carbon that was actually in the rock. And there are some of these deep sea vents, I think this is a picture of one here, very, very deep in the ocean, that are actually making hydrocarbons. They're actually making useful life molecules from scratch today. And, you know, there was a time when the oceans were empty of this. There was sort of a time when it just began. But now what we find is that every single one of these supports an incredibly unique ecosystem, because, you know, you actually have food, hydrocarbons, the building blocks of life forming just from minerals. So the process that forms life didn't stop. It's happening all around us every day. And, you know, the amazing thing to me is we just became complex, and we're able to replicate ourselves and able to modify. I mean, once you've got hydrocarbons, they can start bonding together, and then ones that don't like water are on the outside and form sort of a shell, you know, and then in the inside, you can start to get all kinds of interesting chemical reactions going. It's not really a mystery to science why life began. And like I said, it's happening today in the deep sea vent. That moment of the beginning of life is still going on. So, you know, people were asking questions about, you know, where else do we find this? I wanted to show you, I've got too many pictures. I would love to show you all of this, but there's a moon of Saturn. These are actual images from the Cassini spacecraft. This is an image taken by our spacecraft that spent 15 years out at Saturn. And you can see the rings of Saturn in a very different way. The spacecraft was flying down along the ring plane. And you can see that there's an incredibly thin line going across the middle there. And you can see there's even a little moon, a little tiny moon there. against the planet Saturn. The rings of Saturn are 250,000 miles across, but they're less than 30 feet thick. And you can see the beautiful shadows being cast by the rings on the planet. In fact, Saturn has very interesting seasons because not only does it sort of have a tilt to its axis like we do, but the shadows make whatever hemisphere is in winter much, much colder than it would otherwise. So it has very pronounced seasons because of those shadows of the rings. There's another real picture of Saturn orbiting up around the pole. I just have to show you these because I just think they're so lovely. You just have to realize what we have seen and what is real out there. And this was just for my little, just my gratification. If you notice on the pole of Saturn, there's a beautiful storm that's shaped like a hexagon. And again, this is actually not so much of a mystery. A jet stream at very cold temperatures where there's no friction will do this. And in the middle, there's sort of this eye, like the eye of a hurricane. And I think one of my favorite pictures from NASA is we flew our spacecraft very close down over that eye of the hurricane and took this picture. And this is a real picture of a hurricane structure in there that's, so that the whole storm is about the size of the Earth. So, this thing is many, many hundreds of miles across, and you're looking at walls of cloud catching the sunlight, and the walls are probably 100 miles high. But anyway, this is a picture of Saturn's moon Enceladus. And Enceladus, again, these are actual pictures. We went out to Enceladus. And if you notice, there's all this wonderful ice, and the ice is cracked. And we thought that was really interesting. There are many moons in the outer solar system that have more liquid water than the Earth does. As far as we know, the Earth is in 4th place. There are 3 moons in the outer solar system that have more warm liquid water than we do. But that liquid water is under the ice, under a shell of ice. And when you look at Enceladus, you can see that the ice is actually venting water. The cracks are venting water. This is water flying out into space. And this is what we flew about 30 miles over these vents, and we sampled them. And we found pretty much everything you find in one of these hydrothermal vents. I'll go here. So this is a picture of a hydrothermal vent from the Earth. But we found the same sort of minerals, the same sort of dissolved minerals. We found organic molecules. We found warm water with about the same temperature and as acid level as the Atlantic Ocean. And so we know that there's organics and warm water and a very nice environment out there for life. So that's one of the places that we think that we may be looking. So, one of the things about me, and I don't really know, it's kind of, here, I'll go back to, I've got plenty more pictures, by the way, but let me go back to just see if I can go back to the view where I'm not actually sharing. Here we go. Stop share. Yeah, there we go. We're made of the same stuff that stars pump out when they die, with the same stuff as the rocks. And chemically, that little piece of meteorite that I showed you is more complex than I am. But, we have the structures that that replicate and sort of make this chemistry of life. And as you know, that chemistry of life is very fragile, right? We were talking about my husband who's declined since I talked to you last. He can't really move anymore. And for those of you who have ever done hospice care for a loved one, I salute you. It's not all terrible. There are moments where I still hold him and it's lovely, but he can't really communicate with me much anymore. But what happened is Andrew's DNA just went wrong. That's what cancer is. Some of his cells just started reproducing in a way that wasn't good for his body. And, we try to fight that, but we're sort of these bags of water and organic molecules that almost barely hold together. And, I think instead of making me step away from love and emotion, we had the hospice care people who are wonderful, asked if I wanted a chaplain to come. And I actually asked if they had a Buddhist chaplain available, and they did not here in Annapolis, Maryland. But the very nice Christian chaplain sort of asked why. And I said that, I can't really think of anything outside this life. And we can talk about parallel dimensions and other parts of time if you want to, but just taking this experience in this life, even as painful it is and how fragile we are, the feelings it elicits in me is a huge amount of compassion. We are all in this together. We are all these tiny, brief little pearls of consciousness that then just dissolve, and other pearls form from that. And, there's something about me that wants to, put on robes and go into the woods and ring a bell or something to sort of talk about how beautiful this is, even as it's heart-wrenchingly painful. I mean, last night I had a bad night. It's bad as a judgment. Last night I had a difficult night. I mean, I wanted to sit so still that I thought maybe if I sat so still and didn't move, time wouldn't move either. And I wouldn't have to keep going through these days that are the last days of his life. And there are times when I feel kind of panicked. I can't even really I don't want to go up and sleep next to a dying person again. And there are times I just want to hold him all day. And so we are all in this situation together. And I apologize on behalf of life, for how brief it is and how fragile it is. But the beauty is amazing. I mean, that's the reason I want spacecraft out by Saturn. These are the real beautiful questions. And, we're getting ready to send out more sophisticated spacecraft to go look for life on Enceladus and other moons as well. There's another moon of Saturn called Titan that has a thick atmosphere. And that's one place, if you'd like, we can talk about it, where we might actually have some possible signs of life, very simple chemical life there. I think that there's several places in the solar system that do have life. Just today, we announced the discovery of 100 new planets. We had citizen scientists, untrained people, anybody who can do this, helping us look for that planet 9, planet X, the planet out there in the outer solar system that might be there. Well, they didn't find it, but they found 100 other giant cold worlds around our sun. It's not planet X, these are farther away, but they're still in our neighborhood. And 100 planets just today. We used an eclipse of the moon a couple weeks ago with the Hubble Space Telescope to practice how we're going to find life on these planets. And here, I'll share again and show you how we did that, because that's kind of lovely, because we'll be doing this a lot. So yeah, so with the moon, minimize my zoom window here. So many things. So, I mean, just in the last week, I just wanted to, well, here, I just have to do this. Okay, so here's that giant moon of Saturn. I'll just kind of go through these. Again, a real picture. Titan is about the size of the planet Mars. And you see there, it has a very sort of cloudy look because it has a thick atmosphere. And the clouds are so thick you can't see through them normally, but we have a heat-sensitive camera. And we look through the clouds. And don't mind the sort of square shapes of the image. That's just the detector taking different images. But what you're looking at there, that's the sun glinting off an ocean of liquid methane. So for those of you that wanted to know whether life could be based on something other than water, we know of a world where natural gas falls from the sky, it rains. You're waist deep in organic slush when you're on the surface of Titan. That particular sea you see there is about the size of Lake Ontario. And we are sending a helicopter there in about 3 years' time. We're building it now. A drone, actually. It's an octocopter. It's about the size of a car. And it's going to be exploring this world, looking for life. That's just a map of the lake. So you can see 150 kilometers on the bottom there is the bar. It's a big, big lake. And we actually did send in the early 2000s, we sent a probe down. This is the Cassini spacecraft that they're working on. That silver, it's actually gold foil covered thing was a probe that we sent down. This is an artist conception. Unfortunately, no one was there. We parachuted it down onto the surface of Titan. And there we are coming down over Titan. We saw lakes and rivers and stream beds, and it was raining. And we landed. The probe didn't last for long. Lasted a couple of hours because the surface is about 300 degrees below zero. But at that temperature, the oceans are made of methane and ethane, and it's full of organics. So why not? Why not have life that can live that way? And in fact, we found out that there's bacteria on Earth. This little creature is an Earth creature, but it lives on bacteria that use methane. In the very deepest parts of the ocean, we found bacteria that don't use water so much as they use methane to live. And the amazing thing, sorry?
I've just had a funny question.
Yeah.
It's from Sarah. I have to ask, does it smell like farts there?
Well, so those of you may not know this. This is an interesting thing. I know a lot about farts because of NASA. Methane has no scent at all. The reason natural gas smells bad is they actually add a little sulfur dioxide. And that way, when you smell something bad, you can, there's a gas leak. That's actually not the methane. It's actually an added gas. So methane you can't smell, and we think that the methane would be clear. It wouldn't look like black or like oil. It would actually be clear like water. And because the other thing that I learned, because on Mars, we actually find methane, natural gas as well. And we think it may actually be bacteria. I wish I had time to talk to you about all of this. But I learned that people would say, oh, is that like cow farts? I actually learned that belches have more methane than farts. Farts are mostly hydrogen, now you know. So the main gas of farts is right from the Big Bang, hydrogen gas. Anyway, just this last week, this is a picture of the largest asteroid series between Mars and Jupiter. It's about 600 miles across. And if you notice, there are these odd sort of glowing areas on it. And well, we wanted to know what that was for sure. So we got in closer, and we found out that there is an ocean of salt water pushing up and forming ice underneath these craters. So even on the asteroids underneath the ground, we have warm salt water. Turns out even on Pluto, the farthest world that we've explored from the sun, you know, that wonderful heart shape there is a giant glacier. The glacier is made of nitrogen ice, but we now know that under that is a big reservoir of warm water. So even on Pluto, Pluto is actually covered with organics from meteorites, from just natural organics formed in space. They form so easily. And now we have warm water. This is one of my favorite pictures. This is real. This is us flying over Pluto. The mountains you see glinting in the sun are made of pure water ice, and they're 10,000 feet high over a nitrogen glacier. Just beautiful.
Incredible.
Yeah, so if you're interested, you can go. I took a screen grab today of our website where we track how many exoplanets, planets outside the sun we've found. We've confirmed over 4,200 of them. We're working on another 5,400, following up. And we use the Hubble Space Telescope to practice finding life on exoplanets. And this is how we did it. During a lunar eclipse, if you look at the top diagram, the reason the moon looks red during a lunar eclipse is that sunlight shines through our atmosphere. And it's basically like all of the sunsets and sunrises all around the world. That's the light that gets up to the moon. The sun is behind the Earth, and the Earth is blocking out the sun, but a little bit of that sunlight gets around the edge of the Earth. And that's why the moon looks red during eclipse. It's because of every sunrise and sunset, there's light in a little ring around the Earth getting through. And we use the Hubble Space Telescope to figure out what the chemistry of our atmosphere was based on the light reflecting off the moon. And we found everything we were expecting. We found water and oxygen and ozone and methane and carbon dioxide. And we're going to do the same thing with planets around other stars. This is an artist's conception of one of these worlds. We now know, like I said, of over 4,000 of them. When one of these planets basically does a tiny little eclipse and passes in front of its star, you can see there's sort of a ring of light lit up by its atmosphere. And the atmospheres, you know, the starlight will actually filter through the atmosphere, and we'll be able to tell if there's oxygen and water vapor and carbon dioxide and methane and all of those things. And so we're getting ready now in the very near future to explore these planets and figure out whether there's life there. So I'll stop with the science there. We can talk a bit more about some of the more deeper questions. But you know, some people would say to you that this is a very unromantic and unspiritual view. That, you know, what I think we are is atoms formed in dead stars. Carbon happens to be very good at molecular bonding. Put it in water for a while and off you go. But you and I are really here, and we really have experiences. And, you know, this is the only time the universe gets to know itself through who you are. You know, and I've said this, right? That, you know, so your fears, your insecurities, your pride, your fun, your love, your grief, you know, that's this little tiny bit of, and when I say conscious, I don't think we're as conscious as is possible. We have tiny little brains. You know, what would something, you know, that had 1 billion years evolution on us, what might the experience of the universe? But, you know, the tiny little, whether you're an insect or whether you're a cat or whether you're a human, the tiny little bit of awareness we have, I don't know why. It's something that I want to share, and it's something that I want to celebrate. So that's sort of my take on what life is. A lot of you asked about the questions of time and parallel universes, and these are things that we have a bit less proof of, but you know, one of the things that somebody asked, can you travel to a parallel universe? Something that kind of freaks me out is we probably do it all the time. And my husband was one of the best quantum optical experts at NASA when he was working, and he would make instruments. And if you want, this could be another visit. telescopes, honestly, I'm not making this up. We did a podcast for NPR and I can link to it. These telescopes really only work if multiple realities sort of dovetail together. You need to have a single particle of light from a star, the same photon, the same one, go through several different telescopes at once. And that shouldn't be possible, but it is if you do it very, very carefully and if you do some quantum mechanical tricks. And certainly at very small scales, the nature of reality and whether we're in a parallel universe or not may be very fuzzy and may switch back and forth. This is more conjectural, but I think this is interesting. You may want to research something called the Mandela effect, because it turns out that we're beginning to realize that there are populations of people on the planet that remember different pasts. And one of the things about quantum mechanics says that not only are there multiple futures that you may find yourselves in, or multiple presents, but in fact, the reality you're in now, this moment of now, multiple pasts may have led to. So people might not remember the exact same past. And there's a substantial group of people who really seriously remember Nelson Mandela dying in prison. And the one that kind of freaks me out is a children's book series that I remember being called the Bernstein Bears. This is well documented. The Bernstein Bears was a children's book series. I remember reading them. It never existed. The title was always the Berenstain Bears. And if you look that up, you'll find that that's true, that a substantial number of people remember it differently. So we may be transitioning in and out of parallel universes all the time. It may be sort of almost kind of frothy to the nature of reality. I really admire some of the Buddhist ideas, and I don't necessarily think the Buddhists have, some sort of special line to ultimate truth or anything, but the idea that the universe could have just come to existence now, and it could be over again in 30 seconds. And why do we weep, for things we're attached to, and everything is in flux. Everything is in flux. Mm-hmm. The reality that I'm facing now, many pasts came to, and many futures that are different from now come off of. The idea of loving something so much and trying to be detached. This part of me, this is my personality. I love very hard. I fight against detachment. But even in my grief, I'd sort of like to just go out and celebrate the wonderful wheel and the wonderful cycle of everything that I see here. So what do you guys think? I can always answer more questions, or I'm happy to make this some conversation.
I think Felix is back on his phone, so I'm just going to welcome him back into the fold.
Things to think about.
Thank you, Grace. I'm back in the space. I'm not sure how screen and sound are, but I am here only to ask community questions on behalf of you all. So what I would love to continue is with you personally, Michelle, because last time you talked about getting a tattoo for the first time in your life.
I did.
How's that going? Oh,
well, did I show it to you? So it goes all the way around my body. I think it starts here. So it's Elvish. It's Tolkien Elvish. And yeah, I had never gotten a tattoo before, but when my husband and I were courting, he wrote me a love letter in Elvish, which probably tells you something about how nerdy we are. And he actually did the calligraphy again just a couple months ago when he could still write. And then I had just like old-fashioned carbon paper. I had his calligraphy transferred onto my skin, like this nice little sort of purple paper that ripped off, and then they tattooed it on. So it goes all the way around my back, and then all my other arm. Yeah, and it's an Elton John song. So I really hope that somebody at some sci-fi convention starts looking at my hand and goes, "Is that an Elton John song?" I mean, it's for those. So it's Sindarin, right? That's the dialect of Elvish, and it's the Feorian script. I mean, he knew all the details. I don't speak Elvish, but he does. He's from Oxford, so.
Wow.
See, I got the tattoo. It wasn't that bad. I mean, it certainly hurt, but it was also really fun. I mean, I came out of there smiling. It took about 2.5 hours.
Where did it hurt the most? Asks Sabine in the chat.
I think it hurt the most over my spine. I think that's sort of classic. There's a lot of nerve endings there. So it wasn't over my spine for very long though. So at no point was it ever horrible. No.
Well, I can't thank you enough, and I would like to continue with the community questions here. One question that Jenny asked in the very beginning in the chat is, do we matter?
Well, I think that's up to us, right? I mean, I mean, in a universal sense, right? We are these little chemicals interacting and dispersing. Do we matter to each other? Absolutely. This is our experience of the universe. These are our lives. These are the only ones we get. I don't think that there is, I remember I told you guys last time, I was one night I was observing at Mount Palomar, and we were looking for exploding stars, supernova explosions, the end of a star's life. And we saw 20 of them in one night, 20 solar systems blowing up in one night. And that happens every night and every day all around us. There's no universal importance, except that we are part of this amazing thing, right? But to each other, and the difference we make to each other, and the compassion that we're capable of, and the exploration and the joy. And, I'm beginning to appreciate, and I don't mean to be trite about this because it hurts like hell. I'm beginning to appreciate the beauty of grief as well. This is something that I'm going to let change me in whatever way it wants to change me. And don't mind my cell phone. I should have turned it off. I'm sorry. So, of course, we matter to each other. I mean, I guess my idea of our importance as a species or as an individual is we don't matter to a very large universe, except being a beautiful part of it.
And well, there's a lot of conversation in the chat about which Elton John song it is.
So it's the first verse of the Elton John song, "The One." So it's not one of his best known ones, but it's really, really pretty. So it has the phrase, "When stars collide, like you and I, no shadows block the sun. You're all I ever needed, baby, you're the one." So.
Lots of love for you in the chat here. Thank you, Michelle, for sharing this. And Kyoko also asked the big question in the chat in the beginning: is death and life the same?
Well, I know another person asked the question, are we a simulation? And I think that's a reference to what people are talking about as the holographic universe. There's a lot of drawing evidence now that our perception of time is really, really not the way time actually is in a basic sense. And there's this idea that every moment in time really does exist, and perhaps every version of it, multiple versions of it exist all at once. So I don't know if this is true, but according to the basic way physics is going right now, I've already been dead for billions of years. All the stars have gone out now. That's happening now. And I haven't been born yet. And every moment of my life that was joyful or scary, I think about that a lot, as I lose my husband, that, all of those wonderful times, this isn't just the end of his life. It's just a shape, he's some sort of shape through space time. And this is just part of it. But the part of him where we're having a wonderful time in Paris, or the part of him where we're meeting, that's still there, and that's still now. And, I know I said this phrase before, but we as physicists think it's literally true that whatever the universe is, this sort of large scale hologram, and by the way, hologram does not imply that someone made it. It's the way the universe stores information is very much like a hologram. And we may all be information constructs in that. But, I said to my husband, when the universe began, I was holding your hand. And when the universe ends, I'll be holding your hand. And in some real way, you are eternal. In that sense, we believe that this life and many, many versions of your life, perhaps, really do all exist in this structure we call the universe. So are we important? We're a tiny part of this beautiful thing, but we may be a part of it for whatever time means. And there may be things outside of time as well. But, it could be that when the universe ends in countless quadrillions of years from now, or when dark energy rips us all apart, the moment where I'm holding his hand is still absolutely there and absolutely as real as any other moment. There may be no now, or everything is now. One of the reasons it's hard to get around this is, we talked about light, that light does not experience space or time. To a particle of light, the universe never expanded and time never existed.
And Michelle, Jenny asked us on the Slack if that kind of like your knowledge or your perspective about the universe, how that impacts you in like the mundaneness of daily life. For example, when you're in line at the grocery store or in a traffic jam, do you think you experienced this differently to us?
I don't know. I don't know what it's like to be in other people's head. I really don't. I can't say that, being a physicist, I do think changes everything. I mean, I can still get annoyed, and I can still get, sad. I mean, I'm definitely just a person. I mean, I'm no paragon by any means. But I think everything does change a bit. I mean, I remember, my mom driving me in a car as a kid when I was thinking about vectors and thinking about sort of, how could I keep my hands still as the car turned? So I would move my hands so that it would be still as the car was turning around it. And you sort of find yourself thinking about the physical world and how it works and is put together all the time. So, nothing's really entirely mundane. There's always a little something special going on. Yeah, it's beautiful.
How do you cope with the fact that so many people seem to lose belief in scientific facts?
It's a hard one. I guess this is probably sounding a little bit, overly Marxist of me, but I mean, I don't think that was I think that's deliberate. I think it was politically deliberate to separate us, to take people and get them fighting each other, and then let very rich people cream off the top of everything. I mean, it just seems very politically advantageous that this was set up, to actually get people arguing and hating each other that much. People who have far more in common with each other than they have differences. This idea of just we're Satanists, right? I mean, this QAnon stuff, right? Anybody who's not, a huge Trump supporter is some kind of Satanist pedophile, and that's really what they're saying. It's crazy stuff. I've certainly dealt a lot recently with flat earthers, and there's one credible death threat that NASA had to investigate against me. I get lots and lots of trolls, lots and lots of threats. This is something being done for a political agenda. I wish people could see, what the beauty is and how much we know, even as simple as those pictures of Saturn. I wish they could, these are things we just took a picture of. And the things we know, I mean, we talked to you before about, making elements out of the stars. That's not a theory. When we look so far away in the universe that the light took billions of years to get to us, we see different chemicals. They just didn't exist, before these stars existed. So, I mean, it makes me very sad, but I also have to say, I have a respect for the diversity of humans. We're never going to agree. We do have very different lives, but you got me as to why that's so attractive.
After the next question, I would like to turn the virtual table here to the community for on-screen questions. So to make this a true community Q&A, you can hit the participant symbol on your Zoom app or desktop app, and you will see the raise the hand symbol that will indicate that you have a question for Michelle to ask here on screen. And while you think about that, while you come up with your first questions for Michelle here that you would like to ask her live in person, Michelle, this is kind of like a virtual dinner. If you have the choice of anyone in the world to meet for a real dinner, whom would you want as a dinner guest?
In the world today as an alive, like right now? Oh God! All right, I'll be totally honest with this. I've got a huge crush on Martin Clunes. He's a British actor. He right now he's in Doc Martin, which I don't. That's not how he is. I don't particularly like that character. But I think if you ask me right now, especially because I've been kind of lonely, haven't had much physical intimacy for a year, I think I'd probably say I want to have my man crush, Martin Clunes. As far as other people, what would I love to meet? See, I've actually had the benefit of meeting some of my heroes. I mean, I've definitely had dinners with Neil deGrasse Tyson, with Brian Greene, some of the best scientists in the world. I've just really, really loved seeing them. I think I need an artist. I think I need to. And probably this a wonderful thing, because I obviously asking somebody of Japanese descent, who's that wonderful artist that does all of those mirror rooms with all of the with all the sculptures. It looks like you're gazing off into infinity of color and shape and all that. Yeah, I think I need an artist. So once I get over my my hormones and have my dinner with Martin Clunes.
Thank you. We have the first raised hand here on Zoom. Again, you can click on your participant button and then click the raise the hand symbol on the right to your desktop app. You can see that little symbol of raising your hand. And Kyoko was the first one who hit it. So let's unmute Kyoko. Kyoko, this is your question to Michelle. Great to see you.
You can probably see how much I like Japanese culture. I've got a whole house full of
time. I'm only half Japanese, so
right.
Thank you very much. It's fascinating to hear you. And my question is, so we know that we're part of the universe and we're made of universe stuff, and that the universe is expanding. And pardon me for oversimplifying, I'm just a layperson. But where is the universe located? Where does it sit? Is it part of something? Like, what's beyond expanding? Where? You know, like, where is it expanding to?
Yeah, and of course, you know, like most of the absolute best questions, we don't have the answer to that yet. We have absolutely no idea how big the universe is. The universe, a lot of times when we say the word universe, we're talking about what we mean is the observable universe. And that is limited to the amount of space we can see where light has had time to reach us. So this is actually, again, this is something real. This is not a theory. As you look farther and farther out, the light has taken millions or billions of years to get to you. And eventually you look so far out in any direction on the sky that you look back to a time when the universe was so hot, it was actually opaque. It was like the surface of the sun. So we know that the universe was once very hot and very dense. That's not a theory. Pick any direction on the sky. You'll see galaxies that are millions of light years away. So the light took millions of years to get to you, then billions of light years away. And the farthest we can see is about 400,000 years after the Big Bang, where the universe is so hot, it's actually, the whole thing is like the surface of the sun. We can't see any farther. The universe is absolutely bigger than that, because the universe is not a sphere centered on us. This is just a time effect. Any direction you look back to the time where it becomes opaque. We don't know whether the universe has an end or whether it is truly infinite. But in my case, whenever I hear the word infinity, I get distrustful. You know, we used to think that the earth was infinite, or the ocean was infinite, or the sky was infinite, or space is infinite. I think we just don't know yet what the shape really is. If there are others, how they're nested together. In this very distant fireball all around us, there may be the signals of us interacting with other universes. It could be that when the universe was very small, and again, when I say the universe was small, we don't know how big the universe is, but everything we can see, the observable universe, we're pretty sure was once much, much smaller than the size of an atom. We have evidence of that. But the universe itself could have been infinite even then. That was just the tiny little bit that we can see now. So the universe could have been in another state, very dense, very hot, but we don't know what size it was. So it's not so hard to imagine. The question, what is the universe expanding into, is an excellent question. And it can be answered a couple different ways. I mean, sometimes I use the analogy, it takes a little bit of explaining, where the Big Bang had no center to it. There's no center that all the galaxies are moving away from. Instead, everything in space is getting a little farther away from everything else, unless it's held together by something stronger than this expansion, like the forces between my atoms, the chemistry, the bonds, the gravity that holds me to Earth. All of that is stronger than this expansion of space. But it just seems like it's a property of space itself right now, that space itself is getting bigger. That may be why we experience time. It could be that time is our perception of this change in the state of space. So it's not that we're necessarily moving into anything. It's just that space itself has this property of getting bigger in every direction. So there doesn't really have to be an outside to the universe for it to get bigger, for space itself to expand. That said, maybe it is expanding into something. It's just not in our 3 dimensions. I mean, so when you think about a balloon expanding, remember, the Big Bang has no center. This is not, you're not the center of the balloon. But if you think of just the surface, just the latex of the balloon, as the balloon expands, every part of that latex gets farther away from every other point. There's no center to the latex. We're not talking about the middle, just the surface of the balloon. So it could be that there actually are other dimensions. In this analogy, the latex of the balloon, the surface, is where all of our universe exists. All of space, all of time. There's no up. This is that we're aware of as three-dimensional creatures. That's another direction we're not aware of. So it's possible that we're expanding into a direction we as three-dimensional creatures don't know about. And modern physics thinks that there may be many dimensions. I mean, there may be as much as 11, or the holographic universe says everything is two-dimensional. So I mean, we don't know yet.
Wow.
We just don't know yet. But yeah, you don't need to have anything to expand into. There's no empty center. Nothing is moving through space. That's an interesting point. The galaxies moving away from each other are not the galaxies moving through space, flying through space. It's the space itself getting bigger in every direction at once.
Wow.
And we see this.
Thank you.
So the universe is full of galaxies. There's no empty center.
Thank you very much.
Thank you, Kyoko, for your amazing question. We have Anne, Joel, and John Stewart lined up as the next interviewers. So Anne, here you go. Welcome to the room, and please ask your question to our guest, Michelle.
Well, Michelle, first of all, thank you so much for just sharing this beauty of the universe and your perception of time and space. And I don't know if it's a controversial question. I really don't think there's a right or wrong answer. I grew up in a Catholic school, and I've been told, oh, well, science and religion aren't really compatible. I don't see it that way. But as you're going through all this different process and, thinking about life, you can't help but think about, how your views on religion is, how compatible is it to your view of this universe and science?
Well, I mean, the asking the big questions about what the universe is, about the forces that are bigger than ourselves. I mean, this is the same. This is the same longing in us, right? I mean, it's the same longing that goes back to probably before we were even human, of trying to ask, where do we come from and where are we going, and what is the significance of life and death? And I mean, I think of religion as an absolutely beautiful cultural expression at its best. I mean, I have prayed in mosques in the Middle East. I have been to synagogues. I have been to many Catholic churches. I've given many talks, especially the Jesuits. The Jesuits love me. I'm friends with the observatory of the Vatican. I'm friends with the director of the Vatican Observatory. I've been all over the Himalayas. I've prayed with Buddhists. I've had a chance to experience the beauty of religion and the power and the community of prayer and of spirituality. In some ways, science to me, while it answers a lot of the same, they are separate. Science has to be something that you can show by evidence, and if the evidence changes, you must change your belief with it. So, there were so many astronomers, including Einstein, who did not believe the universe could be expanding. But then when the universe was found to be expanding, everybody has to, once the evidence is there, you have to change. And, with religion, instead you have, the beautiful cultural beliefs that don't change just because something else happens. They're not really linked to that. Science is limited in that you have to be able to do an experiment eventually that anybody in the world could replicate. As weird as we say quantum mechanics is, the reason we think it's real is that any lab in a college, university could replicate some of the experiments of quantum mechanics. Where spirituality is a personal thing. It happens inside your one mind, or your one spirit. And I talked about the universe being, you are unique. You are the one chance the universe gets to live through your spirit, through your mind. And your experience of praise, of religion, of God, that's your part that you get to teach the universe. So, I think, in a perfect world, right? I mean, we could really respect this of each other. I find myself with human psychology. I live inside a human brain, warm and mushy and irrational. I love to pray. I love to worship. I love to dance. I personally interpret that as, this is me. This is my mind. This is how my mind experiences the world. And I think that is informed by science. And to me, the science obviously, I took very much into me. The lessons of science, I took very much into my ideas about life and death and good and evil or any of those things. But, religion can be an absolutely amazing personal experience and then shared in the community of prayer. And, I think we all need to celebrate each other's experiences.
Thank you so much, and for your question to Michelle. And next up is Joe. Joe Weldon, welcome. And here's your question for Michelle.
Michelle, I could spend the whole time thanking you on so many different levels. So I'll just say a big warm thank you for being here and sharing. So I'm going to try to combine this into one question. So I've had two competing thoughts. So you're right. Science does challenge our beliefs, and we challenge our assumptions, and we have the data. We change our beliefs, and we have to. Two questions. What one big assumption has been busted recently that we were like, oh my God, we assumed something, but because of the scientific evidence, it's changed our belief? And then the second part to that question, which I'm struggling with, is a very pragmatic one. How the hell do we learn all this stuff? Because is the learning modalities enough? Are schools learning more about this? How are we educating people about all this stuff? I mean, I read the science section of the Times every Tuesday. That's my extent of science, you know. But is the learning paths enough that people are becoming educated about what we're learning? Because we're learning exponentially, I would assume.
Wow, is that a great question? So certainly, there's so many things right now where you talk about kind of the Copernican revolution, where it turns out, oh, the Earth's not in the center. Well, maybe the solar system's in the center. No, it's not. Maybe the galaxy's in the, no. I mean, of course, the big one that we're really grappling with is that, as far as we can tell, all of the trillions of galaxies that we can see in the observable universe, each one with hundreds of billions or a trillion stars, 100 billion planets, at least in our Milky Way. All of that matter really only making up about 1% of the matter of the universe. So, we think that regular matter made up of atoms is right now about 4%. And about 3% of that is just cold hydrogen gas between the galaxies. It's very difficult to observe, but that's where most of the regular matter is. But the other 96% is in a state we haven't discovered yet. But we're not made of what the universe is made of. Whatever you and I are, we're some little dusting of something that is kind of along for the ride on the rest of the universe. And that's a big deal, because all this we've had inklings of dark matter since the 1940s, when we were studying sort of how galaxies orbit around each other, and then Vera Rubin, famously, one of the first, another woman astronomer who really should have gotten the Nobel Prize for discovery of dark matter, found it in our own Milky Way galaxy, and then now we're, that's incredible. The other thing that, going from the very large scale to the small scale, there's a really great podcast called Veritasium by Derek Muller. I really recommend this. And there's one called What is Empty Space? There's another one called Your Mass is Not from the Higgs Boson. There's another one about that image of the black hole, the giant black hole that they took an image of. He does so many great podcasts. But it turns out that the elementary particles are not little balls. They're actually fluctuating fields, quantum fields. There's really only one electron in the whole universe, because there's an electron field, and where it locally is vibrating, you sense an electron, you measure an electron. But the wavelength of matter extends forever. The wavelength of the matter and the particles that make you up never go to zero. They extend through the universe. And so his What is Empty Space is amazing, because now we find that just, energy, all the way back to Einstein, energy is the same as mass times the speed of light squared. There's a lot of energy that goes into a little mass. But the universe is constantly just vibrating matter in and out of existence. And what a proton really is, they'll show you a picture of this, is just this weird conflagration of interacting fields that are jumping into existence and jumping back out. And this vibration of energy is what we think of as a particle. So, there's no such thing as matter or mass at a tiny scale. It comes in and out of existence so fast, think about that. So, our sense of reality doesn't hold up anymore. And this comes from measurements. This comes from real data. And so, one of the things that we've had to let go of in the last 100 years, the thing about every point in time being real, that goes back to Einstein and Dirac. That's 100 years old. We had to let go of that idea. And now we're having to let go of the idea that anything we really comprehend is solid. There's another great book called Trespassing on Einstein's Lawn by a woman called Amanda Gefter. And Amanda Gefter is actually a Scientific American writer. She's not a physicist, But she tries to see how far she can go down this rabbit hole about what is really real. Is anything in the universe really real? And the answer is no. That there's nothing we can say it's 100% real. So, you know, this idea that our perception, I mean, not just ourselves as a matter of scale, being very big or very small, but, you know, our perception, I mean, quantum mechanics threw it away 100 years ago, general relativity threw it away. Now we're finding out just how real that was. So, you know, there's all kinds of stuff. That's a great podcast, Veritasium with Derek Muller. And for those of you who want to do a little more weird reading, Trespassing on Einstein's Lawn.
Thank you so much, Michelle. Was that, Joe, was that answering your question about education as well?
Oh, education, yeah. So boy, why are we not all taught this in school? So I mean, at least the thing about where our atoms come from, right? How about learning that in middle school? When you learn about chemistry, when you learn about what an atom is and the reason a carbon atom is different from a hydrogen atom, different from an oxygen atom, just different numbers of protons. How did this all start? It's the stars. It's the only thing in the universe that makes a carbon atom, the only thing. And, you know, I mean, I would love to have that in a curriculum. I mean, I didn't have astronomy as a part of my high school science. You know, people are always ready to make fun of people who don't know what causes the seasons and things like that. But you only take a class in astronomy in college if you ask for it, if you take it as an elective. You know, the vast majority of people have never had an astronomy class. They've never seen those pictures of Saturn. You know, we try so hard. But I mean, I would love this to be a central part of education, to know these questions about what is our solar system like, where do our chemistry come from? You know, yeah, we need to know about our neighborhood. Of course, I mean, we could teach kids about geography too, and that's kind of gone down the tubes as well.
Thank you. And we pass it on to the next amazing community member here for his question, John Stewart. John, welcome, and here's your question for Michelle.
Yes, I saw you before with the t-shirt, excellent.
You are here. Yeah, thank you so much, Michelle. It's fascinating, and the way you present it is always makes it even more that way. So I studied astrophysics in college, and I really wish I had kept up, and it was my favorite course. And there was a theory that captured my imagination about the balloon of the universe getting to a point where maybe gravity or something would pull it back in time as we know it would go in reverse, and then we'd go back to the Big Bang and start all over again. And I don't know, I don't know if that's still a possibility or how you feel about that. Or...
It was one of it was one of the main ideas until about 10 years ago. And so there was this idea that, you know, okay, the universe, all of these galaxies have a lot of gravity between them. Eventually, you know, the expansions to start to slow down. And especially when we discovered that we'd missed 96% of the mass, the universe had that much more mass, all this dark matter. So two people who were friends of mine, Brian Schmidt, who I was actually working with at the time in Australia, not with him personally, we were working at the same observatory. And another one was Adam Rees, who I knew ever since I was a graduate student. They were both students of a professor of mine at Harvard called Bob Kirshner. And Bob Kirshner was trying to find a way to measure how much the universe was slowing down over time. And that's kind of hard, because in order to figure out how much, you know, we see around us that all the galaxies are receding. It's called the Hubble constant. You're probably familiar, that they're receding at a rate of 75 kilometers per hour for every 3 million light years you go. So it's not a fast expansion locally, but we can measure how much the galaxies are moving away. But if the rate was different earlier, that'd be hard to measure, because we sort of have measured the local rate. So long story short, they found a way to measure the rate of expansion very far back in time, you know, back many billions of years, about 9 billion years, I believe. And nobody expected this. Everybody's jaws just dropped when they discovered the universe wasn't slowing down, it was accelerating. And this is the detection of this dark energy. Nobody expected it. They were all trying to measure how much the universe was slowing down over time, thinking that eventually it might all recollapse again. That put a monkey wrench in that idea. So that was one of the main ideas probably 10 years ago when you were taking astrophysics. Experimentally now, the universe seems to be flying farther and farther apart and faster all the time. And interestingly enough, there was an inflection point. Something changed 5 billion years ago. And this is what we're designing a mission at NASA to explore. That 5 billion years ago, the universe was actually slowing down. It was still expanding, but the rate was slowing down. And then we reached some kind of critical density. And at that density, we sped up again. And it was almost like there always had been this hidden force, but the universe was holding together. It was dense enough we didn't notice it. And then we got to this density, it just took over. And now a question is, can matter itself hold together over this in the long run? You know, like I said, the expansion of the universe is a very gentle force. It's not making my body larger. It's not ripping the sun away from the earth. If it keeps expanding this fast, that may happen. Really? I mean, so we don't know this. We just discovered this 10 years ago, and my two friends got the Nobel Prize. And now I feel like a real schlub because, of course, you know, when friends from grad school get the Nobel Prize, you're like, what have I been doing? But so we did not expect that result. Right now, it looks like the universe is going to expand forever, but like we know what the universe is going to do, right? I mean, we only popped our heads out of caves a couple tens of thousands of years ago. Right now, our measurements suggest that the universe will expand forever. There's an interesting idea called the false vacuum, which you may want to look into, that says that as we get to lower and lower densities, we may actually drop space and time itself into a new state, and that could set off another Big Bang. That's one of the ideas, that you may still be able to have kind of more Big Bangs if the universe expands so much, you actually drop all of space and time into a lower energy state. Very conjectural. We don't know that that's true. So people are trying to figure out, because it's kind of a dumb idea. The universe begins and expands and then poof, goes to nothing. Then we start asking, you know, why are we in this wonderful privileged time where space and time and matter exist? Or if you believe in many universes, some people have said, isn't it amazing that our universe is so perfect, that matter can exist and life can exist? Maybe we're not the most perfect universe, because it looks like this one may blow itself apart. Maybe a universe with slightly different rules of nature wouldn't have had that, and life could exist for longer. All those ideas come out of that.
Just another small question to take away from this conversation here, of course. And
Yeah.
I would like to point to our banal human time, which I've always find does go away like a second when we speak to you, Michelle. Thank you so much. We have 9 minutes left. We have more music for you. And we will, instead of the breakouts, we will give our 2 community members who have raised their hand the 5 more minutes here with Michelle. First up is Tommy D. Tommy, thanks for being here. Thanks for being a community member. And here's your question for Michelle.
Got it. Thank you. I only spend 13 hours on Zoom all day. I thought I would have figured it out by now. Michelle, first of all, your authenticity and your candor is admirable. And I think I speak on a lot of us to just say thank you for that. We appreciate it. 2 quick questions. Please don't ruin the fantasy for me when I ask this question. Have they been here before? Are they coming back? And to follow up to that, and I think you know who I mean, the extraterrestrials. And also as a follow-up, where do you land on universal consciousness? And I think they're sort of related. So love to hear you on that. Thanks.
Yeah, I wish I had a wonderful answer for you. I mean, certainly in my idea of what's possible, very advanced extraterrestrial life is definitely possible. The whole thing about, you know, visitations and alien abductions, I think once we figure out quantum entanglement, we won't need spaceships. I think that, you know, when you think about, I kind of like the idea of that movie Interstellar with Matthew McConaughey, where there were creatures that had learned how to weave themselves into gravity itself. I think that a lot of times we're just not thinking about what a very advanced civilization might be like. You know, at NASA, of course, we're all about looking for a physical evidence of something. I think I can speak for pretty much everybody at NASA that says we think that advanced extraterrestrial life very well may be possible. The question is the evidence, and if we can all agree on that. You know, there was about 3 years ago, we found a star. Did you hear about something called Tabby's star? I think this kind of shows you that we're very willing to be open-minded. We found a star that seemed to have these giant geometric structures in front of it, something that would resemble almost what people talked of as a Dyson sphere, giant solar collectors that were moving in front of the star. And we followed up on that like nothing. I mean, we did podcasts on it. You can see a wonderful podcast by Tabitha Boyangian. The reason we called it Tabby Stars, because the astronomer that called it was Tabitha Boyangian. Unfortunately, what it turned out to be, at least in the end, we did so many follow-ups that whatever this was is made out of dust. And so we think that maybe 2 planets hit and there were these giant sort of triangles of dust coming off. But it was a chance where for a second or two, and I did podcasts on this before we knew what it was, we wondered if we were looking at evidence of a super advanced civilization that we could see in the sky. And I talked on NPR about, this is a star you could see with a telescope. You could go out in your backyard, you could set up this telescope and you could look at somewhere you knew that there was an advanced civilization. In this case, the evidence turned out that it wasn't. Wow, would I have loved it to be true. I would love to have the evidence, the joy for me. And I think for me, it would be joy and not fear, because if they wanted to meddle with us, they already could. I think people don't have enough imagination. And I think that the idea that very, very advanced beings may know more about these different dimensions, they could be here all the time and we'd never even know. I mean, it's not as simple as flying saucers, So I think that's my take on it. Universal consciousness, well, I'm not overly impressed with human consciousness. I don't think that we're as awake as some people, as other things may be. We don't perceive even space and time the way it is. But what I would say to that is that if all points in space and time are the same, and we're all these little pearls of consciousness that exist for a little bit of time, do you really need more than one? Or can it be the same one looking out of everybody's eyes at once?
Wow. Tommy D, thank you for asking. Michelle, thank you for responding. We have time for one more question, and we have one more hand raised here in the room. Amanda, thank you for being here. You have the last question of today. Here you go. Are you here with us?
Amanda?
Who is Amanda anyway? Amanda, that's all right. If we can't get you, I have hiccups here as well. I don't know what to do, says Amanda. Well, that's what we all share with each other. No worries at all. I guess we have to unmute you.
Could you write your question in the chat?
Just put it in the chat for us, Amanda. And while Amanda is asking this, her last question, I want to thank you all for your time today, and want to just give a quick shout out to next Tuesday, where we host our very first inheritance workshop with our own facilitator, co-star here on Remote Daily, Britt Pham, taking the facilitator helm. We'll be guiding you through your own inheritance. So prepare to find out new things about yourself. And I'm not sure if Amanda has had the chance to share her question yet. Amanda, don't worry if it doesn't work for you today. And we will continue the conversation with and for each other on the Slack channel. I would like to invite you for a final dance of today. This is something new. We have never done it before. And before we dance with Eleanor and Dario, I would like to give Michelle one last, final piece of advice. Is there one thing, Michelle, for today that you would like to share with us? One thing that you would like to take us away from this conversation with you today, other than that we will invite you back because that's already set. Is there maybe one last final piece of advice for your own point in time? One final thought, one final saying.
Well, I guess, I was reading sort of the chat, people were saying, you mean, everything's already happened. It doesn't matter what we do and all of that. Remember that it still seems like space and time to us, and we can still make each other's lives better. And it matters to us what we do, even if there's no external morality or any of that. The other thing I would say is people often make the wrong assumption that I'm not interested in actually being friends, because it's like I'm on TV and they'll see me doing things and they're like, well, I couldn't possibly talk to her or invite her out or, invite her over for dinner. I could really use some more friends, and I need to figure out how to have a new social life soon. So invite me over. I can get to New York. I can get to wherever you are. I can get to Germany. My mom's German.
You are welcome anytime. And you know what? We will invite you to our Slack and continue the question and continue the conversation with you there, because having you as part of our community is one of the biggest privileges and joys and gifts that we could all ever had in our life. And you already have a few invitations to Berlin here in the chat.
I'm going to type my email address in, and please use this sparingly. This is my email address. Right now, as you know, in taking care of my husband is intense. He can't move. I'm doing complete bedridden care, and because of COVID, I'm doing it all by myself. So if I don't respond right away, please, no rejection. I'm just kind of overwhelmed. But this is my email address, and maybe we can start some conversations.
Wonderful. And I also want to give you just all the love and all the respect and everything that I can have in my heart right now for what you're doing in your everyday life right now, that you share with your dear partner, that you've shared your professional life with, your personal life with. You're such an example for being an amazing human being in this time. Michelle, it's been a huge honor to have you back on Remote Daily, and I just want you all to give, to stomp your feet, clap your hands, and give a big, big round of applause for our guest today, live from Maryland, and of course from NASA, Michelle Thaller. Thank you so very much. And Michelle, this is an invitation from many of you to many cities, but now I have an invitation for you to dance it off. What we're doing today for the very first time is a final dance off for the end of the hour, to vent off, to shake it all loose. Of course, with our artist in residence, Eleanor and Dario. If you dance, we might shine a quick spotlight on you. Don't take it as a competition, just shake it. And thank you all for joining today. This is Eleanor and Dario live for you. And if you dance, you'll feel it. Here you go.
Do you remember the 21st night of September? Chasing the minds of pretenders while chasing the clouds away. Our hearts were ringing in a key that our souls were singing as we were dancing in the night. Remember how the stars stole the night away. Hey, hey, ba-di-da, say do you remember? Ba-di-da, dancing in September. Ba-di-da, never was a cloudy day. Ba-da-da, ba-da-da, ba-da-da-da-da, ba-da-da, 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 ba-da-da. My thoughts are with you, holding hands with your heart to see you. Only blue talk and love. Remember how we knew love was here to stay. Now December found the love we shared in September. Only blue talk and love. Remember true love we share today. Hey, hey, ba-di-da, ba-di-da, ba-da-da, ba-da, ba-da-da, 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 ba-da, ba-da-da, 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 ba-da-da. And we say, do you remember? Oh, dancing in September. Golden dreams were shining. Golden dreams were shining things. The bell was ringing, oh, and our souls were singing. Do saying bye.